llm-d focuses on inference, and inference is really the key production workload when you're thinking about building an AI application. Inference's job is really to be the system that takes in a request from the user and then generates text that gets sent back to the user. So it's this really fundamental building block. We often talk about dial tone, super important job that is going to sit at the heart of every AI application that's built on top of generative AI. And llm-d's role within the inference space is specifically focused on distributed inference. So key inference engines, and I personally work on vLLM, which is one of the largest and most broadly deployed projects. vLLM focuses on a single node and tries to make that single node, that single set of GPUs run really efficiently and generate the most possible tokens per second, which translates to tokens per dollar out of that really expensive hardware accelerator. llm-d's job is to orchestrate a whole series of vLLMs, as we go from a single node to multiple nodes, and really looks at those distributed performance optimizations to try to make a whole cluster more efficient, whether this is intelligent load balancing, more advanced techniques like pre-filled decode disaggregation, or multi-node deployments where a single VLM pod runs over multiple nodes. That's really the scope of llm-d, is these distributed optimizations where we're trying to make a whole cluster of VLMs operate as efficiently as possible.
Which, when you think about it, from a Kubernetes perspective, right, CNCF, I mean, Kubernetes supports application patterns really well, microservices. So what's so special about an inference that it can't just fit into the world that Kubernetes already supports?
And it's definitely true today that when most enterprises or companies are going to deploy VLM across a Kubernetes cluster, they often use the kind of standard Kubernetes primitives, like a deployment to add more replicas and a service that load balances across that deployment. This is a totally fine pattern and something that most people are getting started with today. However, as we've started to see bigger and bigger models, I think I was looking back at since 2023 when the open source ecosystem started to today, we've seen a 100x increase in the number of parameters per model. We started with the 7 billion parameters. Today, we now have models with over 1 trillion parameters that are able to be downloaded and deployed. We've also seen a shift from standard deployment patterns with chat or single turn conversations shift to these agentic workloads where we have this kind of multi-turn pattern where the same request gets sent to the model over and over again with additional context. And so as we started to see these trends, it's become more and more important to implement these distributed performance optimizations. And so llm-d really tries to be LLM aware, whereas the standard deployments and services do random, naive load balancing. llm-d tries to understand the fact that it's running an LLM and implement optimizations that can exploit this fact, where we're injecting LLM-aware logic to do things like prefix cache-aware routing to handle those multi-turn conversations you see in agentic workloads, or whether we're implementing things like pre-fill decode disaggregation, which allows you to optimize the pre-fill phase and the decode phase of inference independently, or whether we're implementing things like wide expert parallelism to deploy these very large mixture of experts models across multiple nodes. And so with llm-d, we're implementing all of these key performance optimizations that help you to do that.